F block elements. In F block elements, what we are going to see is what are F block elements. Why F block elements are called as inner transition elements. What are rare earth elements, or otherwise why F block elements are also called as rare earth elements. Electronic configuration and oxidation state of lanthanides. What is Lanthanide contraction? And explain the Lanthanide contraction. Short answer and the long answer. Explain Lanthanide contraction. Explain the consequences of Lanthanide contraction. What are the effects of Lanthanide contraction? These are all the questions and related topics we are going to see here. F block elements. The elements occupies the bottom of the periodic table, that is here S, P, D, F. Here from lanthanum to lutetium, lanthanum, cerium and ends with lutetium, that is here from 4 of 0 to 4 of 14, the electrons are subsequently filled in 4 of orbital. These are called lanthanides. 5F block element starts from actinium with the thorium and ends with lawrencium. It starts with 5F0 and ends with lawrencium 5F14. So lanthanide 4F orbitals are 4F orbital electrons are subsequently filled. So actinides, here the 5F orbital electrons are subsequently filled. Now you can see the table where it shows the electronic configuration. It starts with lanthanum 4 of 0 5d1 6s2. Here ends with lutetium of 4 of 14 5d1 6s2, and here the xenon, it resembles the lanthanides resembles an inert gas xenon configuration, so we are writing it xenon. And half-filled configuration gadolinium, the half-filled 4 of 7 5d1 6s2. Starts with lanthanum 4 of 0 and here the half-filled 4 of 7 gadolinium and ends with lutetium 4 of 14. So called lanthanides. So now we are going to define what are lanthanides. What are F block elements? What are F block elements is the elements which possess incompletely filled F orbitals are called F block elements. There are two F block elements, lanthanides and actinides. Lanthanides starts from lanthanum to lutetium. Actinides are actinium to lawrencium. Here there are from lanthanides 4 of 0 to 4 of 14. Here actinides actinium 5 of 0 to lawrencium 5 of 14, as I said already. Here the general electronic configuration of lanthanides are n minus 2 F14, n minus 1 D 1 to 10, ns1 to 2 is the general electronic configuration of lanthanide F block elements. So what are F block elements? This is the definition. Incompletely filled F orbital, general electronic configuration, lanthanides 4F and actinides 5F. And next one is why F block elements are called inner transition elements. Why F block elements are called inner transition element is here the electrons are moving to the 4F orbital. If it is lanthanides means 4F, actinides means 5F. The electrons are going to the F orbital, which is third level from the outermost level, So F block elements are called inner transition elements. And next one is why F block elements are also called as rare earth elements, as it is rarely abundant in nature. F block elements are also called as rare earth elements. Next one is here we have seen that the F block element general electronic configuration, the electronic configuration of lanthanides and actinides. Lanthanide configuration resembles xenon, so electronic configuration of lanthanide is xenons 4 of 1 to 14, 5d 0 to 1, 6s2. Actinide electronic configuration radon 5f2 to 14, 6d 0 to 2, 7s2 according to the valential configuration. So, this is the electronic configuration of lanthanides and actinides. Next one is, what is the common oxidation state of lanthanides? The common oxidation state, the valency, it shows when it reacts with other elements or the formation of compound. The oxidation state is, the common oxidation state is +3 is the common oxidation state of lanthanide. Apart from that, it also shows +2 and +4 oxidation states. See here in this table, the maximum oxidation state, the common oxidation state is +3, and it also shows the +2 and +4 oxidation state. Next one is, so as usual, on moving from left to right, generally atomic and ionic radii decreases. Here also in the case of lanthanide, atomic and ionic radii decreases on moving from left to right. But the decrease in the ionic radii of +3 cations of lanthanide is, that is more, it decreases more than the expected one. That phenomenon is called Lanthanide contraction. That phenomenon is called Lanthanide contraction. Now we are going to see the what is Lanthanide contraction. The decrease in ionic size, in the case of ionic size is called Lanthanide contraction. So that we are going to see. What is Lanthanide contraction? Now imagine here the electrons are going to the 4f orbital, on here 4f orbital, which is third level from the outermost level. Here the 4f electron, here the present near to the near to the nucleus exposes lesser screening effect. Lesser screening effect means it screens less the nuclear charge. Thereby it screens less, thereby the nucleus attraction over the valence electron, nuclear attraction over the outermost electron will be more, thereby to pull inward. Thereby the size decreases. So reason for the decrease in the size of the lanthanide ions. So the 4f orbital, the lesser screening effect of 4f orbital or 4f electron is the reason for lanthanide contraction. And how it explains the total lanthanide contraction, or how it explains on the electrons are adding from 4f1 to 4f14. How it explains is, imagine here the 4f1, the electronic configuration, only one electron is present. On moving from lanthanum to lutetium, subsequently the electrons are added in the next shell. So the electron increases in the 4f orbital. The concept of lesser screening effect predominates. Thereby the higher effective nuclear charge increases, or by the valence electron experiences total nuclear charge, results in the contraction on moving from left to right. So called lanthanide contraction. So lanthanide contraction or decrease in the size of the +3 cations of lanthanide is due to 4f lesser screening effect of 4f orbital. Effect of lanthanide contraction. What are the consequences of lanthanide contraction? What is the effect of lanthanide contraction is the decrease in the basicity. How basicity decreases is, see here on lanthanum 3+ ions, cerium and lutetium, as the size of the cation decreases, ionic character also decreases, thereby basicity also decreases. Size decreases, ionic character decreases, basicity also decreases, thereby lanthanum hydroxides are more basic than that of lutetium. Lanthanum hydroxide is more basic than that of lutetium. So basicity of hydroxides on decreases on moving from lanthanum to lutetium. And similarities in the atomic and ionic radii of all lanthanides. Due to the contraction, the lanthanide contraction phenomenon, all lanthanides of atomic radii less than 10 picometer and ionic radii also less than 20 picometers. Due to this, it looks almost similar. Next one is due to Lanthanide contraction. Here the F block elements is similar to that of size is similar to that of 3D and 4D transition series. For example, the 3D transition series element tellurium and 4D zinc and 5D hafnium, not tellurium, it's titanium. 3D titanium, 4D zinc and 5D hafnium. Here titanium it is 132 3D and zinc 4D it is 145 and 5D hafnium 144. So the lanthanide ionic radii, atomic radii is almost similar to that of 3D and 4D transition elements. So these are all the consequences of lanthanide contraction. Decrease in the basicity due to decrease in the size. Almost all lanthanides are atomic and ionic radius are similar, and here the atomic radius is similar to that of 3D and 4D transition elements are the consequences or effect of lanthanide contraction.